Today's lesson is called Prime Factorization and Greatest Common Divisor. By the end of today's lesson, you will know what prime factorization is, how to find it of a given number, as well as what is a greatest common divisor of any two given numbers. So first off, we're going to be learning some new terms. Our first new term is called a prime number. This is a number that has no factors other than 1 and itself. So for example, 3 is a prime number. Why? Because only 3 times 1 will give you 3. Another example of a prime number is 13. Why 13? The only way to get 13 is 13 times 1 is equal to 13. So it has no other factors besides 1 in itself. Then our other new number other new term we're going to learn is something called a composite. So this is an integer greater than 1 that has more than two positive factors. So for example, let's pick 6. So 6, the factors of 6 are, we have 6 times 1, which will give me 6, and we also have 2 times 3, that will give me 6. So I have more than two positive factors, these two factors and these two factors. Basically a composite, we need two or more numbers in order to get a composite. So in your notes, prime number and composite. Now our next new term is called prime factorization. So basically we're looking for all the prime numbers that will give us our given number, our product, when we are multiplying. When we're multiplying all those prime numbers, it's going to find our given number. So make sure this is in your notes. Also in your notes, I want the direction. Write the prime factorization of the following: 24 once, twice. I want both 24s in there. I'm going to show you how we're going to find the prime factorization of 24. There's going to be two different ways. So I'm going to break up 24. Now when I'm looking at 24, the first thing I notice that 4 is an even number. Since it's an even number, I know it is divisible by what number? By 2. So I'm going to divide 2 into it and see what my factor is going to be. So now I can break this apart into 2 and 12. Those are two separate factors. Now, why am I circling 2? Because 2 is a prime. How do I know that? Because 2 times 1 gives me 2. So that's why I'm circling. I'm looking for my prime number. So when you find your prime number, go ahead and circle it. Now my 2 is done. I need to look at my 12. Now I look at my 12. What does it end with? It ends with what? A 2, which is an even number, and I know it's also going to be divisible by 2 as well. So let's divide 2 into it and see what happens. I get 2 and 6, and I already know that 2 is my prime number, so I'm going to circle it. Then take a look at 6. I gotta break up 6. Once again, 6 is an even number, so I can divide 2 into it. So I would get 2, and I get 3. And I notice that 2 is a prime number, but also 3 is a prime number. Why is 3 my prime number? 3 is a prime because 3 times 1 gives me 3. 1 is its only factor. So when I figure out all my prime numbers, I figured out it's 2 to the third power times 3. Now you're wondering, how do I get 2 to the third power? Well, if you notice, I have 1, 2, 3 different 2's. If I multiply them all together, I can technically change this to 2 to the third power, but don't forget I have that extra 3, so I multiply 3, and that is how I got my answer. And now this is how we called the factor tree. Now, let's say you didn't notice that 24 can be divided by 2. Let's say you didn't notice that. Well, when I think of another factor for 24, I think of a factor of 6 and 4. So let's break it apart. Let's say we thought of 4 times 6. Now, I don't see any prime numbers just yet, so I keep simplifying. So let's say my 4 I can break into 2 times 2, both primes. And if I look at my 6 previously, I know it breaks up into 2 and 3. So I get my 2 and my 3, both primes, so I go ahead and circle them. And if you notice, do I get the same exact numbers that I did before? Yes, I did. So it doesn't matter where you start. Why doesn't it matter? because you end up simplifying to the same exact number. So you end up getting the same exact prime numbers. So it doesn't matter where you start, because you'll get the same exact answer. Now go and write down the directions. We're going to find the prime factorization. Remember, so basically we're looking for prime numbers. Whoops. Now I'm going to show you using the factor tree as well as something called upside down division. So make sure everything's in your notes, and now we're going to focus on the factor tree first. Now you should notice this ends in a 2. 2 is an even number, so no, it must be divisible by 2. So let's go and break this one apart. So using my factor tree, I know 2 can go into it. So 2 goes into 42 how many times? 2 and 4 is 0, bring a 2, 1. So 21. Now I already know 2 is a prime number, so I'm going to circle it. Now 21. Taking a look at 21, let's see. It doesn't end in even. Let's see, 2 plus 1 is equal to 3. So I know that this is going to be divisible by 3. So I break this apart, and I know it's going to be divisible by 3. Now let's see. 3 times what is going to give me 21? 7 is going to give me 21. And take a look. Do I have any other prime numbers? The question so the answer to that is yes, I have 3 and I have 7. So that means my answer should be 2 times 3 times 7. So those are going to be my prime numbers. Now let's take a look at this something called upside down division. This one is kind of interesting. So once again though, my goal is still to do the prime factorization. Basically we're looking for the prime numbers. So take a look at 42. Now once again, the first thing that should pop at you is that this ends in an even. Since it ends in even, I know that 2 can automatically divide into it. So now let's see. How many times does 2 go into 42? Let's see, 2 times, because we get 4. 2 goes into 1 how many times? 1. So basically I'm just dividing, but I don't have a remainder. So now let's see. I have my 21. What goes into 21? In this case, I know 3 would go into 21. How many times? 7. And since 7 is a prime, I know that's time to stop. And if you notice, I end up with a 2, a 3, and a 7, just like I did over here. So what's my answer? My answer ends up being 2 times 3 times 7 as well. So 2 different ways of doing it, whether you want to do the factor tree or practice doing the upside down division. So in your notes, write down the directions as well as example number 1. So looking at example number 1, what they want us to do, they want us to actually multiply this out. So let's first expand out my exponent. So that ends up being 2 times 2, then times 3 times 5. So then I end up getting 2 times 2, which is 4, times 3 times 5. 4 times 3 is 12, times 5, and then 12 times 5 gives me 60. So then 60 is my answer. So they ever ask you to find the number of that prime factorization, all we're doing is we are multiplying. Just multiply it out. Now in your notes, we're going to learn something called the greatest common factor. So the greatest common factor, what is it? It is the largest number that divides evenly into a given set of numbers. Now there are 2 ways of finding the greatest common factor. One way is you can make a list of factors, or you can select the common factors from the prime factorization. So it's up to you which way you prefer. So make sure that everything is in your notes. So in your notes, make sure you have the directions, and I want you to just first focus on the make a list portion. We're not worrying about the prime factorization portion first. So we're just looking at make a list. So with making a list, basically you're just looking for all the different factors. So for 10, automatically it should always be 1 in 10. Let's see, this ends in an even, so I know 2 times 5 will give me 10. 3 won't work, 4, 5, 6, so nothing else works. So those are all my factors. Now let's take a look at 45. Now 45 automatically you should know is, hey, it ends in a 5. So let's see, I have 5 and I have 9. Oh, I have 1 and I have 45. let's see, 4 plus 5 equals 9. So I know 3 divides into it. Let's see how many times 3 will divide into 45. 1, 3, I get 15, 5. Okay, so we have 3 and 15. I already did 9. 1, 2, 3, 4, 5, 6, nope, 7, 8. Okay, so I have all my factors, but what does it want me to do? It wants me to find the greatest common factor. So let's see, what do they have in common? Well, they have 1 in common, but that's not much. They have 5 in common. Looks like this. So it looks like my greatest common factor is going to be 5. Now let's test it out with prime factorization and see if this is correct or not. So looking at prime factorization, let's look at 10. So 10, the first thing I can think of is just 2 and 5. 2 and 5 are prime factors, so I'm going to go ahead and circle those. Now let's go and take a look at my 45. So 45, automatically I see that 5, so I'm going to think of 5 and 9. I already know that 5 is a prime number, so I'm going to circle it. I know 9 I can simplify down further. 9 is going to be 3 and 3. Those are both prime numbers. But remember, our goal here is to find the greatest common factor is. So what do they have in common? That's your question you're asking yourself. What do they have in common? So if I take a look, they don't have any 2's in common, don't have any 3's in common. What do they have in common? They have a 5. So my greatest common factor is 5, which I already proved over here. So different ways. You can either make a list or use prime factorization. Either way, you will get the same exact answer, the correct answer. So in your notes, we're going to find the greatest common factor of the following. Make sure you have 6m squared, 9mn. We're going to be dealing with variables, so I'll show you what you do. So first off, let's look at our 6m squared. Always separate your constant from your variables. And then let's see, let's focus on my 6. I know 6 can be broken up into 2 and 3. Okay, those are both primes. So go and circle U, circle U. Now for my m squared, how can I simplify that down? Well, basically it just ends up being m and m. So this one we're done with, totally done with that one. Now let's worry about our 9mn. So let's see. First off, always break apart your constant from your variables. I know 9 can be simplified down further. Simplify that down into 3 and 3. Both primes, let's go and circle them. And now my mn, how can I break that down any further? Basically just breaking apart my m and my n. Now remember, greatest common factor. We're looking for what they have in common. What do they have in common? So let's take a look. So my greatest common factor. Let's see, they have 1, so they have a 3 in common, so I bring down my 3. Let's take a look at my variables. Now, I don't have an n, but I do have an m over here and an m over here. So it would be 3m is my greatest common factor. Be very careful, we're always looking for what do they have in common. So this would be my answer. So go and write the directions. We're going to try to find the greatest common factor using our upside down division. So make sure you have your 12 and make sure you have your 18 as well. So first off, you need to take a look. What does this end this? It ends in a 2, which is an even. So I know this must be divisible by 2. So I put 2 on the outside. So how many times does 2 go into 12? 2 goes into 12 6 times. Draw my division sign again. So let's see, how many times, what can go into 6? Once again, I should notice this is an even number. Even number means that 2 can go into it. How many times does 2 go into 6? Goes into it 3 times. And since these are all prime, I know I can stop. So I have a 2, and a 3. Now let's take a look at our 18. Now once again, you should notice this ends up being an even number. Since it's an even number, I know that 2 can go into it. So how many times does 2 go into 18? It goes into it 9 times. So then I draw my division sign again. Now what can go into 9? First off, everyone should automatically think, oh, 3. How many times does 3 go into 9? 3 different times. Once again, I look. I have only prime numbers, so 2, 3, and 3. Once again, greatest common factor. Greatest common factor. We're looking for something in common. What do they have in common? So if I notice, I have a 2 right here and a 2 right here, so I bring down my 2. No other 2's, but I have a 3 right here and a 3 right here. Times it by 3. What's 2 times 3 would give me 6. So 6 is going to be my greatest common factor. So if you like to, you can go and try to use upside down division. So I'm going to write me a 2-sentence summary of what we learned today. We learned about prime numbers, composite numbers, greatest common factor, prime factorization, how to find those numbers. Which way do you prefer? Do you prefer the factor tree? Do you prefer upside down division? 2-sentence summary. Let me know.